So here's a couple quick, easy lessons on alkane isomers. We've talked about them in class. If you're watching this video, there's a possibility also that you're watching this before class as well. I recommend watching it before, during, and after. You might be able to get a little bit out of it each time. So we've talked about alkane molecules and that alkane molecules are essentially alkane, when it ends in ane, that simply means that we know we're going to have single bonded carbons. Single bonded carbon atoms. So that means in the molecule itself we would see a carbon, and we know that carbon has 4 valence electrons that can form around it, so we know that there would be a bond that could form here, there would be a bond that could form here, bond that could form here, bond that could form here, and various atoms can combine around here. Carbon will also bond to itself. And when we talk about alkane isomers, an alkane molecule is basically a hydrocarbon. And a hydrocarbon basically just made up of hydrogen and carbon atoms. So the simplest alkane molecule would be one with one carbon atom with 4 hydrogen atoms combined. Compound formula would be CH4, and we would call this methane. So again, alkane molecules, you could have 1, 2 bonded together. If we had 2 bonded together, there'd be a hydrogen here, 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 and here. 2 carbons together, we would call that ethane. If we happen to have 3, again, everywhere where I'm just drawing a bond, if you put a hydrogen in each of those spots, the next we see methane, now we see ethane, propane. Okay, you see they all end in A and E. These are all alkane molecules. So right here we can see this is C2, H1, 2, 3, 4, 5, 6. Here you can see this is C3, H2, 4, 6, 7, 8. And if you look closely, you will notice that let's go to 4 in a row. That's 1, 2, 3, 4. Well, not 4 in a row, but 4 atoms that are carbon atoms single bonded to each other. 1, 2, 3, 4. So you can see here there would be a hydrogen here and here. So this is a CH2. This is a CH2. This is a CH2, and this is a CH2. And by the way, the name of this 4 in a row is butane. So if we were to look at a pattern here, you can see how there's 1, 2, 3, 4, and then there's 2, 4, 6, 8. Well, 8 is basically 4 times 2. So if we look at the ratio, if we were to think of the ratio of carbon and hydrogen atoms, for every 1 carbon there seems to be 2 nitrogen. And we notice that we have a hydrogen here on the end and a hydrogen here on the end. So that means we have 2 more hydrogens. And this pattern right here, this mathematical ratio, it holds true for all of our alkane molecules, all of our alkane hydrocarbon molecules that are straight chain isomers. So an isomer meaning that you've got multiple molecules that have the same chemical compound formula but might be structured differently. So that's where we're going here with this. So now notice you have 1, 2, 3, 4. There's 4 carbons, and then 4 times 2. So N is 4. 4 times 2 is 8, plus 2 more would be 10. And we can see here 2, 4, 6, 8, 9, and 10. All right, so each of these is what we would call a straight chain isomer. Okay, so isomer, same. So that's just a general term that is used. So right here, there are no isomers for this particular type of molecule. Okay, and no isomers for this one. What I mean is there's really no other way to bond this together, these three carbon atoms, and for there to be a different molecule with the exact same formula. However, if we take a look at butane, all right, let's take a look at butane. What we're going to notice is that we could take butane and go 1, 2, 3. Now imagine we just picked this carbon up here and pulled it off. And I moved it somewhere, say to here. And then we know, following the octet rule, that each carbon wants to bond 4 times. So if we follow that, we've got 1, 2, 3, 4, C4. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, H10. Excuse me. So we see here C4H10 is 4 carbon atoms bonded this way, but C4H10 is also 4 carbon atoms bonded this way. So isomer is the fact that both of these have the same compound formula, but they are structurally different. They're chemically bonded differently. So for that reason, even though they have the same formula, and by the way, we call this an empirical formula. We'll talk about more of that in future lessons. But empirical formula just basically means what's the ratio of all those atoms together. We're just going to combine them all together. It's just all the atoms right there. It's like the simplest formula that we can find. Okay, that's a good working definition for right now. So right here we see that no matter which way we go on right here, we can see here that there's 1, 2, 3, 4. Well, there's 4 atoms. That's the long chain. If you follow this path here, you see 1, 2, 3. You see that if you follow this path here, you see 1, 2, 3. Or we can just follow this one, 1, 2, 3. Either way, we see that there are 3 carbon atoms bonded in a row. That is our long chain. Well, we know from up here, the long chain 3 is propane. And then we see right here that there is a single carbon extension. And this carbon extension is called an alkyl group. And we name our alkyl groups the same way we name our hydrocarbons. So if we look up here, we notice that one carbon atom by itself, the hydrocarbon atom by itself, a carbon bonded to hydrogens, we call methane. All right. So if we come back down here, we'll see that this is one carbon atom that has 1, 2, 3 hydrogens on it. One carbon atom we know is methane, but what we do is we drop the ending. We drop the ending and we add a YL. So this becomes methylpropane. Now, the next thing we have to do is we have to ask ourselves exactly where is this extension located. If we imagine that this chain is longer than 3, then we could see that this branch could be on multiple different carbons. So right now, if we were to count 1, 2, 3, or 1, 2, 3, this carbon is always, or this extension is always on carbon 2. So we want to make note of that in the name, that this methyl group is on the second carbon. And so this is what you need to remember for naming, is that this part right here is the long chain. This part right here are the branches, the alkyl groups, the branched groups. And another name for that we call a substituent group. Okay, it's called a substituent group. And then right here, this basically is where it's at, where the alkyl group is. So just remember this little jingle. Long chain, extension, where's it at? Long chain, extension, where's it at? If you remember that, you can never go wrong with your isomers. Okay, so that's the quick introductory lesson on isomers, and we'll have a more complicated, well, not more complicated, but a more in-depth one here in the next video. Hope you enjoyed this. Hope this helps.